This is Algebra Lesson 1-6, Multiplying and Dividing Real Numbers. A multiplicative inverse of a non-zero rational number, a divided by b, is b divided by a. Okay, often referred to as a reciprocal. A reciprocal, a multiplicative inverse, and its reciprocal must equal 1. So, for example, 1 over 2 times 2 over 1. 1/2, the reciprocal of 1/2 is 2 over 1, and when you multiply those together, you get 1. These are multiplicative inverses. So negative 3/5, the multiplicative inverse of that is negative 5/3, because we have to get a negative 1, or positive 1. We need to make sure that they're both negative. So when we multiply all these together, you still get 1. Those are multiplicative inverses, otherwise known as reciprocal. So the rules for multiplying real numbers are related to the properties of real numbers and the definitions of operations. So you know that the product of two positive numbers is positive. 3 times 5 is 15. You've been doing multiplication of positive numbers probably since 3rd or 4th grade. You can think about the product of a positive number and a negative number in terms of groups of numbers. For example, 3 times negative 5 means 3 groups of negative 5. So 3 times negative 5 is the same thing as saying negative 5 plus negative 5 plus negative 5. And we know the rules for addition tell us if the signs are the same, we keep this common sign. So negative 5 plus negative 5 plus negative 5 is negative 15. So you can also derive the product of two negative numbers, such as negative 3 times negative 5. So if 3 times negative 5 is negative 15, we're going to start with the product of 3 times negative 5 is negative 15. If we have the opposite of 3 times negative 5, that's going to be the opposite of negative 15. The opposite of two equal numbers are equal. Then we take a negative 1 times 3 times negative 5. We just replace that negative with the opposite as being a negative 1, and that's the multiplication property of negative 1. So negative 1 times 3 times negative 5 is a negative 15, which is the associative property of multiplication. So negative 3 times negative 5 equals negative 15, which is another way of saying positive 15. So negative 3 times negative 5, that should be a negative 5, not a negative 15 right there, is positive 15. The opposite of negative 15 is 15. Coming to this and understanding this, that illustrates our rules for multiplying real numbers. It says the product of two real numbers with different signs is negative. If the signs are different, they're negative. A negative times a negative is a positive, but a positive times a negative is a negative. The product of two real numbers with the same sign is positive. So if the signs are different signs are negative, same signs are positive. Okay, so if I have two positive numbers, my answer is going to be positive. If I have one negative and one positive, my answer is going to be negative. If I have two negative numbers, my answer is still going to be positive. Okay, so if we understand that, find a product. 9 times negative 7. I have one negative sign. Okay, I've signed, they're different signs. So since they're different signs, it's going to be negative. So 9 times negative 7 is negative 63. Okay, letter B here, 32 times 0.5 or half. 32 times a half. Both of those numbers are positive, so the answer is going to be positive. So half of 32 is 16. Letter C, 1/2 times negative 5, 6. We only have one negative sign, so one is positive, one is negative, so my answer is going to be negative. Okay, I multiply straight across the top. 5 times 1 is 5. Straight across the top bottom, 2 times 6 is 12, so I have negative 5 twelfths. And this last one here, we have negative 5 squared, which literally means negative 5 times negative 5. It's not the opposite of 5 squared, it's negative 5 squared. So negative 5 times negative 5 is positive 25. Another little rule I like to teach people about this is if you have an odd number of negative signs, your answer will be negative. If you have an even number of negative signs, your answer will be positive. Odd number of negative signs equals a negative answer. Even number of negative signs your answer will be positive. For example, let's say I do Negative 1 times 1 times 1 times 1 times negative 1 times negative 1 times negative 1 times 1 times 1 times negative 1. Okay, I know my answer is either going to be negative or positive 1 because they're all 1s, but let's count. Let's count how many negative signs we have. We have 1 negative sign, 2, 3, 4, 5 negative signs. So 5 is odd. Means it's going to stay negative, so my answer is going to be negative 5. Okay. If I had, let's say, negative 1 times 2 times 1 times 1 times negative 1 times negative 1 times 1 times 1 times 1 times negative 1. Okay, if we count how many negative signs we have, okay, I have 1 negative sign there, 1 there, 1 there, 1 there. I have 4 negative signs. That's going to give me a positive 2. Oops. Negative 5. How did I get negative 5 way up there? This should be a negative 1. I have 5 negative signs, but my answer is still negative 1. Silly me. Just goes to show we all make mistakes and need to pay attention to our work. All right, now let's look back at letter D here. Notice that the negative 5 squared. Okay. Notice that negative 5 squared is 25. So recall back to lesson 1-3 that a is a square root of b if and only if a squared equals b. So negative 5 is a square root of 25 because negative 5 times negative 5 equals positive 25. A negative square root is represented by a plus and minus. Okay. Excuse me, a negative, I'm sorry about that. A negative square root is represented by a negative square root sign. I lost my square root sign there. Every positive real number has a positive and a negative square root. The number plus and minus in front of the radical indicates both square roots. So be careful when working with exponents. The expression negative 3 to the 4th actually means the opposite of 3 to the 4th, or negative parentheses 3 times 3 times 3 times 3. Therefore, you would evaluate 3 to the 4th first and then take the opposite of that. But negative 3 to the 4th, the negative sign is inside the parentheses, so it is part of the base, and therefore negative 3 to the 4th means negative 3 times negative 3 times negative 3 times negative 3. Okay, so if you're careful, this means negative 81, where, excuse me, positive, no, negative 81, where this means positive 81, because here you're going to have negative 3 times 3 times 3 times 3, which is 9 times 9. And here you're going to have negative 3 times negative 3 times negative 3 times negative 3. We have 4 negative signs, so this becomes positive 81, and this becomes negative 81. All right, find the simplified form of each expression. We have the negative square root of 49. Notice the negatives on the outside of the square root symbol. So we're not asking for both the positive and the negative root, we're just asking for the negative root. Well, what two numbers multiply together that are exactly the same equal 49, and that's 7, so this would become negative 7. Letter B asks for the plus and the minus, which means they want both the positive and the negative square roots. Okay, so the square root of 4 is 2, and the square root of 9 is 3. Since they want them both, we have plus and minus 2/3. Letter C here, we have the square root of 64. Then this one does not ask for negative, doesn't have the plus and minus sign in front of it, so it's only asking for the positive square root, or what we refer to as called the principal square root. So what two numbers multiplied together equal 84? That would be, 64, that would be 8. So the answer here is 8. All right, the rules for dividing real numbers are related to the rules for multiplying real numbers. So basically the rules stay the same. If you have different signs, your answer is going to be negative when you're dividing. If you have same signs, your answer is going to be positive when you're dividing. The only thing we have to pay attention to is division involving 0. The quotient of 0 in any non-zero real number is 0. The quotient of any real number and 0 is undefined. In other words, 0 divided by 8 equals 0, but 8 divided by 0 is undefined. Think of it this way. If I have 0 divided by 8, I have 0 cupcakes and 8 people at my house. Each person is going to get no cupcakes because I don't have any to divide between my people equally. If I have 8 divided by 0, I have 8 cupcakes, but nobody at my house to divide them between. So if I don't have anybody to divide them between, there's nothing really to do. So this is undefined. Division by 0 is undefined. If you put it in your calculator, it'll tell you error. You cannot divide by 0. You can't take something and divide it into 0 groups because you're not dividing it. It's impossible to divide it if you're not dividing it into groups. So it's undefined. All right, let's take a look at a word problem here. You have made 5 withdrawals of equal amounts from your bank account. The total amount you withdrew is $360. What is the change in your account balance each time you make a withdrawal? A withdrawal means you're taking money out. Deposit means you're putting money in. So you go to the bank and you make 5 withdrawals from your bank account. Maybe 5 weeks, maybe a week apart, maybe a month apart, whatever. But each withdrawal is for the same amount of money. Okay, and the total amount of money you withdrew is $360. So if we think about this, we're taking $360 and we're taking out 5 withdrawals. 5 is negative, or withdrawal is negative. So we're taking 360 and dividing it by -5. Okay, and if you don't have a calculator handy, or you just want to do this by hand, 7 times 5 is 35. So $72. You're taking out $72. Your account is going down by $72 each time you make a withdrawal. So the change is forget your $. And the reason I ask you guys to put this in a complete sentence is because it's a word problem. Every time you answer a word problem, you should answer a word problem in a complete sentence. So the change is -$72 each time. So don't say you withdrew $72, -$72 each time. You could say you withdrew $72, but you can't say you withdrew -72 because withdraw means negative. Negative is negative, so you'd have 2 negatives in a row, which makes it a positive. So it's better to just say the change, because it asks what is the change. This is the change in my account is -$72 each time. All right. Now, when you simplify, we need to make sure that we pay very, very close attention to all our negative signs, especially when we're substituting values in, when we're evaluating things for another number. Whenever you evaluate and you're putting in a negative number, that negative number always goes in parentheses, especially when dealing with exponents. I just like to do it, for this particular problem, number 1 here, I have the opposite of c times d. So I have a negative parentheses, -8 times -7. Actually, that looks like a dot. So -8 times -7 is -56. Excuse me, positive 56. So these two, because I have 3 negative signs, so my answer is going to be negative altogether. But these two make a positive 56, and then I apply the negative on the outside and it becomes -56. I actually prefer to just count the negative signs and figure out if it's going to be positive or negative. Here, this says the opposite of c. Well, c was -8, so we have a -8 times -7. Okay. So we have another 3 negative signs, or we can think of it as the opposite of -8, so we could think of it as 8 times -7. Either way, I have 3 negative signs or I have 1 negative sign. Both of those are odd, which means my answer is still going to be negative. Here I have c, which is -8, times the opposite of d. d is -7. The opposite of that would be +7. So again, we have -56 here. And last but not least, we have -2 times -3 times c times d. So -2 times -3 times c, which is -8, times d, which is -7. I have 1, 2, 3, 4 negative signs, so I automatically know right now my answer is going to be positive. And we can multiply these in any order we want. Well, I know that this is 56. I know that this is 6. 6 times 56 is 336. And it is positive. Okay. Now, these negative signs are going to become very critical when you start dealing with exponents. Number 1 here says -4 to the third. It actually reads the opposite of 4 to the third. It's not -4 to the third, it's the opposite. Opposite and negative basically mean the same thing. However, notice there's no parentheses here. So this is saying the opposite of 4 times 4 times 4. That's what it means. It means the opposite of 4 to the third. 4 times 4 is 16. 16 times 4 is 64. So this answer would be negative 64. Number 2 is negative 2 to the third, which means negative 2 times negative 2 times negative 2. We have 3 negative signs, so it's going to stay negative. Negative 2 times negative 2 times negative 2 is negative 8. Please don't say negative 6. That's the most common mistake students do. Instead of taking 2 to the third, they just multiply 2 times 3, which is not right. So be careful. Okay. It becomes critical because if you notice, negative 2 to the third, negative 2 to the fourth. Problem number 3 says negative 2 to the fourth, which basically means this. Negative 2 times negative 2 times negative 2 times negative 2. I now have 4 negative signs, which means my answer is now going to be positive instead of negative. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, so my answer is going to be 16. Okay. Notice how 2 and 4 are similar problems. 2 was negative 2 to the third. 4 is the opposite of 2 to the third. So 4 means the opposite of 2 times 2 times 2. So 4 here, 2 times 2 is 4 times 2 is 8, is negative 8. We get the same answer because the exponent is odd. If the exponent was even, that would change. Like if we look at problem number 3 and problem number 5 here. If you look at problem 3, we have negative 2 to the fourth, and problem 5, the opposite of 2 to the fourth. So problem 5 says we're taking the opposite of 2 times 2 times 2 times 2. So that's going to be 16, and we take the opposite of that, it's going to be negative 16. So notice how 3 and 5, the answers are opposite of each other because the exponent is even. That's when it's going to become very, very critical. If you don't pay attention to those exponents and when they are inside when your negative sign is inside the parenthesis or outside the parenthesis, you're going to make some monumental mistakes, and that will compound itself later in some of the other things that you do. All right. Now, remember, when we divide fractions, we're multiplying by the reciprocal. Think keep, change, change again, because it's basically what it means. Okay, same thing. Keep, change, change. We did it with subtraction. Now we can do it here with division. Keep the first fraction, 3/4. Change the division sign to a multiplication sign, and change the negative 5/2 to its reciprocal of negative 2/5. Okay. And we can simplify. We can multiply straight across the top, which in this case would be negative 6, straight across the bottom, over 20, and then reduce. Or my preferred method is to look at it and say, 2 goes into itself once, it goes into 4 twice. So now when we multiply, 3 times negative 1 is negative 3, 2 times 5 is 10. So there's the answer in simplified form, negative 3/10. If you look at letter B here, 1/2 divided by 2/3, keep the negative 1/2. Change the division sign to a multiplication sign and change the 3/2 to 2/3 to 3/2. Okay, nothing cross cancels, so multiply straight across the top. That's negative 3, and 2 times 2 is 4. Okay, that's just a quick review of things that you should have learned back in 5th and 6th grade math, and definitely been reviewed in 7th and 8th grade math. All right, so answer the following question for me at in the bottom of your notes or the end of your notes. Is it possible to square a real number and obtain a negative product? Explain. And if it's not possible, give me a counterexample.